Well, we decided in discussing things at the class time last week to add a little bit about modeling and monitoring Chesapeake Bay. Models started as large-scale physical model. There was a 1 to 1,000 physical model housed in a big warehouse on Kent Island at the site of the old ferry terminus before the Bay Bridge was built. And just for scale, the guy sitting on the left there is by the Elizabeth River, just one little small micro tributary down Norfolk of Chesapeake Bay. So the bay itself model was huge, and there's actually a book written about this hydraulic model. So that's the way they could simulate and understand the flows within the in the bay, and they used that. It was operated by the Army Corps of Engineers. But of course, now computer models have taken over, and there are a whole suite of models. And for each of these bubbles in this diagram, there's a suite of different airshed models, different watershed models, water quality, hydrodynamic model, and the living resource models. But the Bay program really has one operational uh, model for each of these that it uses for the regulatory mission in particular. And there's a bunch of contractors that work outside. Army Corps of Engineers still actively involved out of Vicksburg, Mississippi. But the on-site on the Chesapeake Bay program campus, there's this half a dozen modelers, two Americans, an Indian, two Chinese, and a Peruvian. So it's United Nations of different talents that apply themselves to the different parts of this equation. In addition to these six, there's another uh, uh, bunch of folks that feed data into these models. And what we see from those models are outputs like this. This is the Chesapeake Bay hydrodynamic model. In this case, looking at different salinity levels based on different flows that come from the Susquehanna in particular. So, pretty dry on the left and very wet on the right. And the model has connectivity to the ocean, has large ocean grid, so it's influenced by offshore uh, processes as well. So really, there's very little controversy about this. So that the hydrodynamic, the physical model was up until the 70s and early 80s, and then the computer model. So they've had decades of developing this modeling capacity. The watershed model is a little more contentious. It's a little goofy the way the Bay program has done it because they've been contracted with the state of Virginia to do the entire state, which portions of which are not within the Chesapeake watershed. So the rest of the model, the watershed model, and you see a county map, the counties that are impinged on that, and then the darker color, green on the left or reds on the right, are the actual watershed, but including Western Virginia. And this watershed model has lots of little grid cells and does all kinds of uh, transformations of air deposition and water runoff from different land uses, and then transformations downstream. But the models uh, have had a contentious history, and one of the more important things that happened was a front page Washington Post in which the models being used to judge the progress of the Bay restoration were starting to be relied on a little too heavily, and in really what was happening was when the farmers would put a best management practice in, they would fit into the model as if totally achieved, and that caught people's attention. In this case, a cartoon that sort of highlighted the fact that the scientists at the Bay program were looking at their computer without looking at what was going on in the water a little too much. So as a result of that outing by the Washington Post, there was and the people who read the Post, the congressmen and senators in the D.C. area, called for the Government Accountability Office to review the Chesapeake Bay program, and that led to a series of recommendations as well as successive GAO audits, and then Office of Management and Budget (OMB) came in, Inspector General for EPA. So lots of scrutiny with the Bay programs kicked off by that initial article in the Post. And then, and you see that one of the key things was in this recommendation was to implement an integrated assessment approach, revise it to improve the effectiveness and credibility of its reports, and so that's what helped stimulate this Chesapeake report card. The other thing that's been happening sort of in parallel to the Bay program focus on models and getting those good, the best possible model to use in this regulatory fashion is that the scientific community as well, which includes the agencies, the federal agencies, and the academic institutions have developed a whole suite of additional models. And there's this community modeling program, which one of the tenets is to have this accessible open source models so that you can go in and really test it and tweak it. And so that's developed a whole modeling capacity outside of what's happening in the Chesapeake Bay program itself. In terms of the monitoring, there's a huge amount of data collection that goes on by four major approaches. One is to use satellite remote sensing, and if you go to the Eyes on the Bay website, you'll see daily uploads of remote sensing images. There's underway sampling where the boats travel through the water, and a pump takes the water up and measures as the boat's continually moving, so you get this high density, hundreds of samples for chlorophyll or things you can measure photometrically, temperature, salinity, of course. And then fixed station sampling, which is where the boat drives to a place, stops, spends half an hour to an hour doing depth profiles, collecting water, filtering it on site, and then going back and analyzing for nutrients in the laboratory, or chlorophyll in the laboratory. Then there are a bunch of continuous monitoring sites, and these are either some buoys out in the bay operated by a bunch of different agencies and organizations, as well as on docks in the shallow water, and these measure typically 15-minute intervals for things like turbidity, temperature, and salinity. Now, all that data, those 10 million data points a year, go into a mixed bag. And when back in 2003, this was the list of 101 indicators that were being tracked in the Bay program. The problem was they were just kind of thrown in together as a big mixed bag, no hierarchy of importance or overarching indices, and some of them were mixing messages. So there was seagrass, aquatic grass, total acreage, along with aquatic grass acres planted. Well, there are many zeros difference in that. The fluctuations from year to year in the natural abundance overwhelmed any paltry efforts in the restoration field. So it confused people, and they none of them were telling a story. They were just indicator by indicator. And the lag time was so long that sometimes you're reporting about a full year later, and of course in a full year's time period, a lot could have changed, and some had poor spatial representation. So we needed to kind of clean this up, and it's been done through a series of manners and reported out. And this is the Bay Barometer, which was released last week, well, the 31st of January. And these are tracking data from the early 90s through, well, in some cases back to the 80s. Things like blue crabs or rockfish, dissolved oxygen, and water clarity. And from those you can see these long-term temporal trends in some of these parameters. And as well as they can be displayed spatially. And these are two maps from the Chesapeake Bay report card that the EcoCheck report card, and that's using the 166 fixed stations around the bay for the water quality on the left, and then aerial overflights for the aquatic grasses on the right, ground truth aerial photography. So in these cases we get the dense spatial representation. So from all these monitoring and modeling efforts, those are, I mean, the real challenge here is how to integrate both of those to represent the best possible spatial temporal resolution, as well as provide some forecasting capability to look at different scenarios for management options and looking at trends over time that have to do with land use or climate change. So this is just a quick snapshot of some of the modeling and monitoring efforts going on in Chesapeake Bay.